Hi, Max. Thank you for making time today.
No
So
problem.
this one is just really a shallow dive into the internals around Opossum. So, can you give us some insight into what the tool is, how it's made, what coding, what architecture decisions, and why it's effective and where its bottlenecks or cons might be?
That are a lot of questions.
Keeping you on your toes.
Let me start by, I think, the first question, how it is built and what the technology stack is. It's a React desktop application that is running in Electron. So that's basically a Chromium, something that's just providing us the JavaScript environment to run React. And in that it has a backend and a front end part, and the backend provides the data to the front end, and the front end just renders that. And the backend has a state that is basically the input file that gets put into that application, and it keeps track of all the changes that are made, and that's the output part of the state, and that's frequent or always written to an output JSON. So immediately when you start, it starts writing an output file. So if you are done, the output file is already present and contains all the information. So that's the basic architecture idea.
I guess we move into performance next. And one observation I had, people sometimes take pot shots at the Chromium code base for performance reasons. But my broker account, I use a pro broker account. Our trader workstation recently moved to a Chromium-based app. And as you can imagine, that's a lot of data with necessity to execute really fast. So it was impressive that they moved. They moved from a Java code base onto, I guess, an Electron app. And apart from the fact that I got a thing saying Chromium wants to send you notifications, there was no other visual or performance indication that the code base had moved. So I'm guessing, for you, the performance and so on was pretty good with this code stack. You had no concerns.
Yeah, performance is was for us a huge concern. We wanted something that we have snappy, that is fast to click around, and that immediately shows all the notification. I think until now we have nowhere a loading spinner when you use the application. I think there's some exceptions where still a lot of work is exporting data and stuff, but when using the application, you should never hit a loading spinner or anything. So it's
this was really noticeable in the last discussion we had where you were showing the GUI, and it's really snappy. It's very fast compared to what I'm used to with a lot of the applications we see. This one seemed to have zero lag. And you explained that fundamentally it's because the data structures that it creates are what it uses to display. So it doesn't have to do an intermediate and translation of the information.
Yeah. The hierarchy of the file of the folders and file structure, that's exactly how we store it in the input file. It's built to be that object of objects, that cascading map thing, and you can just navigate around in that, and you don't need to pass everything just to display one section, and in that one section you have all the data present. So that's a huge advantage.
And how about cons? Is there any kind of decisions that were made with engineering that could lead to it having some limitations and so on?
For sure, yeah. Its file-based approach obviously comes with some cons. So right now it's a local thing that you run, and it's not interconnected to a knowledge base. So to get new information into that loop when you're working, you need to regenerate the input file, you need to run that again. And I think there would be the opportunity to improve that with a shared knowledge base in the backend, something that already knows previously generated packages, that already knows huge set of harvested packages, or that starts with a knowledge base. So that could make the process way faster of identifying content, and that could also help to share content. And if you have multiple scans in multiple runs in parallel, you probably want to share the identifications as fast as possible, so that there could be some improvement if we directly communicate that back. But that's hard to keep that and to have that, and at the same time have this high performance. So that's the trade-off there.
And of course, because the code is permissively licensed, if someone wanted to work on integration into, let's say, a software catalog, they can do so. There are some pre-existing software catalogs. I know that SW360 tends to be used in-house by a few companies, and there's also Clearly Defined, which has information about software. What I understand from what we've said so far is currently it doesn't integrate with catalogs like this, but of course it could, and that could offer some benefits with some drawbacks on, let's say, speed.
Yeah. I think the hugest, biggest benefits are if you start typing a package name and you have completion.
Yeah,
that already is great.
That is
and
good.
if that ensures consistent naming with your software catalog that you're using, that would be a huge gain.
Now, when it comes to the scanning tools that it calls, and this isn't on this tool, but it's calling tools, how are you finding concurrency nowadays on the scanning tools? And I ask that because scanning used to be pretty slow. And nowadays, of course, we have such multi-core chips, like where's my direction? That's a Linux server with, I think I've got 24 cores. And that type of concurrency is fantastic, but until recently, a lot of tools just didn't support that type of thing. They had a little bit of concurrency, and then they were bottlenecked by I/O. But nowadays, with Gen 4x4 NVMe, you don't have a bottleneck, and with the cores, you don't have a bottleneck except your code. And have you found that concurrency is working well these days?
Yeah, I think scan code especially is able to just consume all the CPU power that is there. So if you let that tool loose, it will eat your whole CPU and heat the room.
Yep.
So that works great for the high compute section, or for example, also for the OSS toolkit run. The high compute parts are mostly scan code if you do the scan stuff. So that's good, that works. I think some other tools that we have not yet integrated, but for example, for storage, would more rely on scheduling parallel tasks, have multiple scans in parallel, but every one on a single core. I think that's still results in the same throughput, but is a different approach. There are some scanners that we have integrated, for example, dependency track, I think, that still runs, not dependency track, that was the OVA's dependency check tool. I mixed that up, sorry, dependency check. That tool still runs on a single core and takes a little bit, but it would be an easy fix to run that in parallel to scan code and just take one core from scan code. So I think you could do it. It should work great, and it should be a good thing. I still think if you run the OSS toolkit with all its deep scanning of, so with scanning all the dependencies, it still takes a huge time invest to get that done. And there's still the possibility to improve that by sharing results or having something pre-computed and using.
And when ORT is doing that, and we're going to do a big deep dive into this tool in ORT later, but just out of curiosity, when ORT is doing that, is it doing a lot of read writes to disk as well? I know that might be out of your remit. It was just a random thing, because I know if you've got even the fastest NVMe drive, when you exhaust the SLC cache, you go off a cliff. So, after a certain amount of data you hit a wall.
I don't think that that's the issue with Auth. I think Auth basically pulls source code, runs scan code, and after that pulls the next source code. And I think scan code itself runs in memory and does not write to disk a lot. It's reading all the files sequentially, but that should be fine. I don't think that it writes a lot. It writes a final JSON in the end, but that should be a single blob. So hopefully the NVMe shouldn't be the bottleneck here.
And of course, nowadays with RAM so cheap, you know, having 128 gigabytes of RAM is no bother. And now, if people watch this whole segment in concurrency and we're like, why did Shane start by saying concurrency doesn't matter to this UI, and then dive into it's because the UI doesn't need that much concurrency, and it's already an Electron app, so it's already concurrent. So it's already performant. Then I guess the last question I have on this kind of internals thing was, how modular is it?
That's a hard question. I think there are several aspects of modularity. So I could imagine one direction of modularity could be to build the security aspect into that. And for that, you would need to touch the input file. The input file right now is a JSON file, and it's evaluated against a schema, but that schema is allows for additional properties. So you could introduce here additional properties in the input file. That's the first part where we have modularity. The more complex part is the UI. You also want to display that information correctly. And we are still lacking concept for that. So we don't have a plugin concept or the something like that. I think it's it would be good to have something like that, although it's still at a stage where I would take that as contributions and put that into the main thing. So I don't think that a plugin system would work, especially since that pins us to a fixed API. So my approach for modularity would be contributions and add additional tabs to the UI, and maybe make it with feature flags, so that the security tab, if that would be generated, only is displayed if security information is available. So that would, I think, would be a modular approach.
And that makes a lot of sense. I mean, making the UI more configurable fits into a nice to have, but the immediate problem space is what we're seeing addressed. And on the back end, of course, the way it works is you're essentially plugging into other tools. So, you know, for a mental model for someone thinking about this, can it work with another tool? Absolutely. It plugs into other tools. You'll build a bit of bridging code. So in that sense, for that mental model, yes, it's modular enough to plug into anything. And on the display side, which is its main purpose, it's already addressing the key thing. So I guess, you know, there we have it, that to expand the UI probably needs community contribution, so people care enough to create that, as opposed to just putting stuff in there because it could be done. And the interface is very clean and nice already, so it'd be a shame to mess it up. More buttons is not better. More buttons is not better.
Yeah, absolutely. That's I think one of the hardest drivers. Which button deserves to be somewhere, deserves to be on every entry, which icon is worth all this clutter, and that always is a push and pull, and we try to keep it clean, keep it simple, and that obviously conflicts with having all the features, all the possibilities in the tool at the same time. So that's probably the hardest part in extending the tool. And if there comes a new set of features like vulnerability specific IDing of components and identification of stuff, if that gets its own tab, in the UI, it has its full freedom to be specific to its own use case, and it does not clutter the other UIs. I think that's a good approach.
I think that's a really good approach. I'm a pretty strong believer in contextual user interface, right? So if you're doing compliance, then you switch to security, you should have what's needed for that context. Putting everything in one place is a recipe for inefficiency. And going back to the trading scene, you'll find that trading interfaces often have different contexts, because like someone used an old view that's been going for 20 years and they still have it, but no one modern would want to use it. So there's a tab and you click and the entire thing changes. And those contextual options are just super useful, especially because you've got different teams on security to compliance quite often. Yeah. So we've got a React interface. We've got an Electron app. We've got, when you're looking at the technology in it, it's basically Chromium and some other stuff. It's highly performant. It calls other applications, and it's pretty lean, as far as I understand it. You've designed it for this problem space. You've got as little bloat as possible, and you're going to see what the community needs to build on.
Yeah, exactly.
All right, Max, thank you for this whistle-stop tour. I'll be releasing this as a little video to the community because they've had the graphical user interface chat, they'll have this chat, and then next month we're going to deep dive into ORT and Turn, so people will really get the nuts and bolts.
That sounds great. Looking forward to that.
Likewise.